Number 3 here. Ask for the length of the interval of the x-axis on a graph of a function if the average rate of change is, in this case, 1.7. So you're given the average rate of change, okay? And you talk about an interval of the x-axis, right? And you're also told how much y changes, okay? So my question is, how do you interpret that in terms of a graph? Well, first thing somebody said is a slope, okay? It's actually an average slope. So, average rate of change is a slope, average rate of change of f of x is a slope associated with the graph. Of f of x. So if you've got a graph of f of x and an average rate of change, well, how would I do an average rate of change for some point, or some, yeah, how do you do an average rate of change for a graph?
Like 2 points.
You got to have 2 points on the graph. We'll just say those 2 points, right? Fair enough? So the average rate of change is what? It's the slope of the fundamental triangle. Okay? Between 2 points on the graph. So now we've got a picture of an average rate of change in terms of a graph, right? Because anytime you got a question about an average rate of change, you're probably going to want to think of it in terms of a graph. At least it won't hurt you to think of it in terms of a graph and the slope of a fundamental triangle. And to have a fundamental triangle, you got to have 2 points on that graph. Okay? So that should be automatic. Then you can start trying to see what the problem actually asks. Okay? But since the problem talks about an average rate of change of a function, you know that you're talking about a fundamental triangle somewhere between 2 points on the graph of that function. Okay? Now, what's the problem tell us? It tells us average rate of change is 1.7, which means what?
Slope 1.7. Average slope.
Okay, so that means the slope is 1.7, and I hope you understand that convention, but that's what it means, okay? And that arrow should reinforce the fact that that's what it means. Okay, so the average rate of change is 1.7. What else do you know?
Y changes by 0.6.
Slower.
Y changes by 0.6.
Okay, y changes by whatever it says. Didn't hear the word 0.6? Yeah, that's what I thought I heard. Okay, good. Okay, you're talking better.
Sorry.
Okay. Y changes by 0.6. What's that tell you about the fundamental triangle?
Rise.
That's the rise. So the rise is 0.6. So let's draw a little bigger version of this fundamental triangle. We've got 1.7 here, we've got 0.6 here. Now what can we do with that information?
You can find the run.
You can find the run. How do you do that? Well, you can look at it and hope that you do the right thing with those two numbers, or you can write slope equals rise over run, which is the safe thing to do, and it doesn't take long, right? Or you could write delta y over delta x if you wanted to. But rise over run is a thing you kind of will always remember. Okay? And now what are we trying to find? We know the rise and the slope. So what do? Well, we can say slope is 1.7, so I'm going to put 1.7 here where slope was. I'm going to put the equal sign where the equal sign was. I'm going to put 0.6 for the rise. And I'm going to divide that by the run, and I'm going to solve that equation for the run. So, what am I going to do first? I'm going to solve this by superstition, or am I going to use valid procedures? If you get it by superstition, okay, I'll pretend you got the valid procedures, sort of. But if you screw it up, expect a stiff penalty. If you get to this point, you got a lot of partial credit, though, if you got a picture and everything. You're still not going to get more than 6 or 7 points out of 10 if you don't solve that equation correctly.
Divide both by the run or multiply 1.7 by 0.6.
Don't think I'd do that. Maybe one of those is correct, maybe not. Didn't sound like the first one was correct, though. Okay? What do you have in this equation that you always look for? It starts with D.
Denominator.
What do you do if you have a denominator?
Multiply it out.
Multiply both sides by the denominator. Multiply it out, I know what you meant by that, but that's a little too vague if people don't remember the. So you do run multiplied by 0.6 over run equals run times 1.7. So that run times 0.6 over run is run times 0.6 divided by the run, which is run over run times 0.6, which is just 0.6. And this equals run times 1.7, and then you know that you can divide both sides by 1.7, and run is 0.6 over 1.7. Okay, there's a pitfall there, because I think what you told me, and even though you're really pretty good with this stuff, I think you told me to divide 1.7 by 0.6. Multiply, yeah, I didn't understand C code. Okay. All I'm saying is, it's a common pitfall when you get here to do the wrong thing if you don't remember your basic rules of using equations. If you try to skip a rule and use superstition, you're very likely to screw it up. And I see that quite frequently. Okay? Make sense? Cautions. Now, what does the problem ask you? Okay, well, you know, all I've done here is I've taken the information in the problem and I've translated it into a fundamental triangle, and now I know all three sides of the fundamental triangle, right? I haven't even looked at what the final question is. I know that given this information, I'm going to do this, and then I'm going to see what the question's asking so I can finish answering it, right? And what's the question asking? It's asking, what's the interval of the x-axis? I think. I forget what the
What's the length of it?
Yeah, the average rate of change of f of x, and on that, what's the length of the interval? That's the beginning of the question. I was looking at the end, okay? What's the length of the interval?
The run.
Yeah, well, the length of the interval, here's the interval. And the length of that interval is equal to the run because of right angles and all that stuff. So there you have it. Does that make sense? Now that problem is phrased in a way that you're not familiar with, but if you understand fundamental triangles and their relationship to average rates of change, you can make a lot of progress. If you're doing that problem, I just saw the fundamental triangle, I'd give you some credit. If you got the fundamental triangle with the numbers on it, you get more credit. If you do something sensible with the numbers and screw up the algebra, well, you're going to lose a few points. Okay? And somewhere in between there, you get what you get. Hopefully you get it all. And the point of that is you start with what you can do with the given information and keep plugging away until you get somewhere. Okay? I'm sorry, what were you going to say?
So the run is 2 5/6.
Again?
So the run would be 2 5/6.
Well, if that's what you get when you divide 0.6 by 1.7, but it looks like, to me, like that's about 0.36 or something like that. Not 0.3, yeah, 355, 354, something like that.
Did
Point-
6 over 10 divided by 17 over 10, then flipped it, so 6 times 10 is 60, and 10 times
Or
10
take your calculator and divide it out.
I don't have a calculator.
Well, they have them in the testing center, so when you're taking the test,
Fair point.
okay, we know that you're going to have a calculator available, not a graphing calculator, that'd be absurd. Nobody'd learn anything, they'd just use the graphing calculator, which is, of course, what everybody's taught to do. Okay, make sense?